Hi, I'm gonna solve today problem 2101, detonate the maximum bombs, and by the look of it, it seems like a graph traversal problem. Now, looking at what I have, it says that I have a list of bombs, and it's a 2D array. The range of a bomb is defined as the area where its effect can be felt, and this area is a circle with the center of it at the location of the bomb. Now that makes sense. So I have a bomb here at 2,1. That's the center of it. Now the bombs are represented by a zero index 2D integer array. Each entry in this 2D array is a bomb. Therefore, it's an array which represents a bomb. So bombs I has the x and I, which are the x and y coordinates, and the radius which it can affect. In this problem, I have to start by detonating a single bomb, and this bomb will detonate all the bombs that lie in its range. And these bombs that are in its range will in turn detonate the bombs that lie in their ranges. So I can sense some recursion here. Now, we are given the list of bombs, and the goal of this problem is to return the maximum number of bombs that can be detonated if we are allowed to detonate only one bomb. So let's take a look here. If I take the first example that they gave us, if I detonate this bomb at 2,1 with a radius of 3, its effect won't reach the other bomb, and therefore this bomb will be detonated by itself. This will result in one bomb being detonated, whereas if I detonate this one at 6,1 with a radius of 4, its effect will reach this bomb, and therefore this again will be detonated. So I'll have a result of two bombs being detonated. Now, if I look at example 2, if I start from this bomb, this one has a radius of 5, so it will detonate, but it won't affect the other one. And this one will also detonate if I start from it, but it won't affect the green one. And therefore, I need a radius that's greater than 12, since the distance between these two is 12. I need a radius that's greater than 12, so I can detonate the two at once, and therefore I'd return 1. So for example 1, I'd return 2. For example 2, I'd return 1, because that's the maximum that I can reach if I start with one bomb. To solve this, before going with the main graph traversal implementation, we'll need some helper functions, like we're gonna find the distance. That's something we know. So let's see. Let's start by writing these, and I'll start by creating a method to find the distance. Let's make it private, and it's gonna return a double since we have square roots and squares here. So it's gonna take 2 points, point 1 and point 2, and we're gonna find the y distance, and we have the same for the x distance. We're gonna find the absolute value, or the absolute value of the distance between the 2 points. Let's remember here that we have each bomb represented as x, y radius. So that's why points 2, 1 refers to y, and points 2, 0, index 0 refers to x. So this is point 2, 0 minus point 1, 0. And then I can use the hypotenuse, and it will return the distance. What I'm doing here is that I have 2 points, so this is point 1 and this is point 2, and I'm finding the x distance between them and the y distance, and therefore I have a right triangle the total distance will be the hypotenuse of this right triangle. So I'm returning math.hypotenuse, hypot of the y distance and the x distance. Now, I wrote this inside the function. I need to write it here outside of the function. It's a function by itself. This is not Python. Besides that, my plan is to try detonating different bombs, starting from different bombs. So if I have 5 bombs, I'll try what starting from the 0th bomb would give me, what starting from the first bomb would give me, what starting from the second would give me, and so on. And therefore, I'm gonna go have a for loop, and in this for loop, I'm gonna take every bomb. I'll call it a start bomb, and this is a for each here. So for each start bomb and bombs, I'll have to do some exploration. For every bomb, I'll find the number of bombs that it can detonate, that the number of the bombs in the chain reaction that it will start, and I'll store the maximum value, and therefore I need to store this maximum value. I'll create therefore an integer called max bombs, and I can initialize it to 0 or to min value, and at the end I'm gonna return this. So I'm gonna return max bombs, and it will end here. Now, what am I gonna explore? For every time I start a chain reaction or I start detonating bombs, I need to keep track of those that were detonated. I can't detonate a bomb more than once, and therefore I need some hash set to keep track of these, and we'll find what to put here in a bit. So let's call it detonated, and it's a new hash set. And I have an array. My bomb is represented in an array. So I either have to create a new class and put it here inside the hash set as the type, or I need to find another trick. I'll try to find a less resource intensive trick to do that. My idea would be to change this bomb to a string. So instead of taking the coordinates and joining them in a class, why not just use a string that represents this bomb? So I'm gonna create a helper function that takes a bomb and returns it as a string. One way to do it would be to return bomb 0, which is the x coordinate. I'll add commas to be on the safe side, plus bomb 1, which is the y coordinate, plus its radius. So what if I have 2 bombs located at the same point but with different radii? That would be safer to take into account the radius. Yet this is not very safe. Like, what if I have my input as 4, 1, 3 and 4, 1, 3. I have 2 similar bombs at the same place. These would be returned as one string, and since I have a set and the set doesn't allow duplicates, this stringification, or this function, the stringify function, won't do its work. They will be registered as one bomb, and therefore I'll think of an alternative. One way to do it is to return what I receive when I print an array. Since when I print an array without using arrays to string, I'm usually left with the class and the hash for that instance. I'll use that as a unique identifier to my array, and therefore instead of doing this whole thing, I'm gonna return bomb.toString, and I'm not using arrays to string. I'm just returning the object and the hash code of that object. So therefore, I'm gonna use here a string, and of course, using a hash set to keep track of things that we visited, or in that case, bombs that were detonated, is a good idea, since it has constant time. Adding to hash sets and retrieving things from them is usually constant time. So that's a good choice to go for here. When I visit a bomb, when I start from a bomb, it's supposed to detonate, and therefore I can safely add that bomb to the list of those that were detonated. So I'm starting with every start bomb again with an empty set of detonated bombs, and I can add my first bomb to it. So stringify start bomb. At the end, I'm gonna use a function. So I'm gonna have a function here to find the number of detonated bombs. I'm gonna use that function and compare the number of detonated bombs to the max bombs that I have. So I'm gonna write a private function, and also stringify can be private here. So back to this, let's call it detonate bombs, and it's gonna take the original bombs to the array. It's also gonna take a start point, and it's gonna take the hash set of detonated bombs. I'm gonna therefore see how many bombs I can detonate from that start bomb. So I pass bombs, start bomb, and detonated, and compare it to the max. Therefore, I can write max bombs equals math.max, max bombs, and detonate bombs. What's left is to fill detonate bombs, and here I'm gonna use some DFS. I'm gonna use what I know about DFS, which is depth first search, to find how many bombs I can detonate. I can also use recursion. So I'm gonna start in a for loop. I'm gonna take all the bombs that are in the original input and see if they're gonna explode. So I'm gonna take, for each test bomb in bombs, I'm gonna take each test bomb, see if it will be detonated, and if so, I will add it to the detonated set, and at the end, the size of that set will signify the number of bombs that were detonated, and therefore I can return detonated.size. Since I need to find if a bomb was already detonated or not, I use the stringify, and since I'm gonna use that stringify more than once, I'm gonna store it in a variable, and therefore I'll have a string called bombRef, which is a reference for that bomb. So I will stringify test bomb. So if detonated contains bombRef, I'll do nothing. But if it doesn't contain it, I will see if there's a possibility that this will detonate or not, and therefore I'll add a not here. So this not is for the case where a bomb wasn't detonated. If it's detonated, it already did its job. I won't deal with it again. So if it's not detonated, I'll try to find the distance and see if it will detonate. So if find distance of start point and test bomb, I will see if the distance between the point that I started from and the test bomb is less than the radius of the bomb that I started from. So if it's less than or equal than start point 2, again 2 is the radius, this bomb will detonate, so I'll add it to my set. And I will check which bombs will be detonated from this bomb in turn. So I will check detonate bombs of bombs, test bomb, and detonate it. Now, let's run this code, check if we have some unseen errors. I forgot an R here. Is there anything else? No, and if I run it on the example test cases, it seems to work. However, submitting this will result in an exceeded time limit. This is very slow. It can be made faster, but before we move to another approach to make it faster, let's see if we can, within this approach, improve it. Let's try a little trick. If I detonated all the bombs and therefore max bombs would be equal to bombs.length, I can definitely not detonate more than that number. Therefore, if max bombs is equal to bombs.length, I can return at an early stage. I don't need to go to another start bomb. Therefore, I can type here if max bombs is equal to bombs.length. I'll check that. In that case, I'll directly return bombs.length. Now, this is probably error-free as well. And if I submit it, I'll get a very slow solution. In fact, it took 1600 milliseconds, whereas the graph here reaches 500 maximum. So my solution was accepted, it made the cut, but it's very slow. One reason is that I'm calculating the distance between, let's say, bombs 2 and 3 multiple times. For every start bomb, if 2 detonates, 3 is being checked. So let's say I have 10 bombs, I'm doing this check 10 times. This is not an efficient way to do it. So we'll keep the same logic, yet at the same time do the calculations much less. We'll try to do the calculation if a bomb can explode its neighboring bombs only once. Therefore, let's reset this. In the previous part, we did graph traversal, but it was tedious. We're gonna try to do the graph traversal in a more classical way. We're gonna try to translate the input so that our computer can process it as we usually do with other graph traversal problems, with problems that are obviously graph traversals. So therefore, I'm gonna keep this maximum detonation, and I will need a helper function just like before, which will check if a bomb, which will check the distance between two bombs and accordingly judge if these two bombs will be detonated or not. But this time, I won't return the distance. Let's return right away if these two bombs can detonate each other or not. So let's write a helper function, and instead of calculating distance, let's call it can detonate, and it's gonna take x1, y1. It's also gonna take the radius of the first one, since the first one is gonna detonate the second one. We don't need the radius of the second one, yet we need its coordinates. Usually, when we calculate the distance, we need to square root the sum of squares, but here we'll keep it squared and compare it to the radius squared. So I'm gonna say distance squared, and it's equal to x2 minus x1 squared. So that's again x2 minus x1 plus y2 minus y1 squared. Instead of calling math.power, I'm just multiplying each one by itself. And I also have radius squared, which is equal to r1 times r1. And if distance squared is less than radius squared, then I'm gonna definitely detonate. So I will return if distance is less than or equal, so this squared is less than or equal to radius squared. Now, I can write the first part of my solution. So my solution will consist of translating the problem into a simpler graph traversal one. And the second part will be performing DFS and finding the maximum detonated bombs. So for the first part, I'm gonna use a for loop to traverse all the bombs. So for int I equals 0 till I less than bombs dot length I plus plus, I'm gonna take that bump. So let's call it current bump, and it's equal to bumps I. And then I'm gonna take all the other bumps. So for int j equals 0, j is less than bumps dot length j plus plus, I will check all the bumps that car bump can detonate and put them in a list for it. To do that, I'll need a hash map. Now I can write the hash map inside the function or outside of it. Now if I write it inside of it, I need to pass it to the DFS. If I write it outside of it, I don't need to pass it with the DFS. This comes with some downsides if the class is reused, but since here we're doing it for solving this problem only, it's okay. So I can just type hash map here, and in this hash map, I'll call it map. I will put an integer and a list of integers. So I'm mapping an integer to a list, and therefore I'm somehow saying bomb 1 can detonate bombs 2, 3, 5, and 9. Then say bomb 2 can detonate 3, 6, and then I'll say bomb 3 can detonate nothing, and bomb 4 can detonate bomb 1, and so on. We chose a hash map, again accessing and adding and retrieving from a hash map is O of 1. I can also use a list instead of a hash map. That won't make much of a difference. I can use a list of lists instead of using the hash map. I'm gonna map these bombs into my hash map. Therefore, I will take the dest bump, and it will be equal to bumps j. And if I can detonate the dest bump from the current bump, I will add it to it. So I will check if can detonate car bump 0, car bump 1, which are the x and y, car bump 2, which is the radius, dest bump 0, and dest bump 1. So if I can detonate dest bump from car bump, I will add dest bump to the list that corresponds to car bump. Now that list might not exist, so I can go to map. I will just add that list if it doesn't exist. So map.put if absent I and an empty array list, and then since I know that I have the list now, I get that list and add to it J. Therefore, I checked and found that 4 can detonate 6, so I will add 6. And then I'll keep checking and find that 3 can detonate 2, but 3 has an empty list, so I will add a list for 3 and then put 2 in it. Okay, so the first part is done. We transferred our input into a list of lists or a set of lists which show the bombs that each bomb can detonate, and therefore I don't need to repeat this calculation every time I change my start bomb. So what remains is to take every start bomb as we did before and see the maximum number of bombs that it can detonate. I'll create a variable called max, and it's initialized to 0, or it can be initialized to min_int, and I'm gonna take each bomb here. And again, I'm using I since I'm not using the for each, since I'm referring to these by their indices. And at the end, I'm gonna return max. I'm gonna find the number of detonated bombs using DFS. So I'm gonna write the DFS in a bit. So I'm gonna give it I, and I'm gonna store the bombs that exploded also. I'm gonna therefore pass an array for that. Afterwards, to cut things short, if I detonated all the bombs, I can return right away, and otherwise I'll do the maximum and compare it to the detonated bombs. So let's write the DFS for this, and I'll call it DFS this time, and it's gonna return the number of checked bombs, the number of detonated bombs, and I'm gonna pass to it a node, which is initially the starting bomb, but this can vary since this is recursive, and the visited bombs. So I'm gonna pass an array that stores the visited bombs, and therefore if I have 10 bombs, I will have a Boolean array, and in this Boolean array I'm gonna be storing true if I visited it, false, false, true, false, etc. So every bomb that's detonated is represented with a true. And as in any recursive thing, I need to define my base case or my return case. And in that case, if a bomb is visited, it already exploded, and therefore I don't need to add its count. I can directly return 0. So since I'm passing I, this is what I passed here, this is the I. So if visited I is true, then this bomb already did its job, and I'm gonna return 0. Otherwise, I'm gonna mark this bomb as doing its job, since it's gonna be detonated right now. And since it detonated, my result is 1. This is the beauty of recursion. I'm gonna return the result at the end, but it might not be 1. I might add to that one. So this bomb exploded and my result is 1 at that time, but I'm gonna check if it will detonate other bombs. If the bombs that it can reach were already detonated, I will add 0. Otherwise, I will add the number of those bombs from the recursion. So I will go through the list of all the entries that this bomb can detonate. So if I have 1, if I'm at bomb 1, I just detonated bomb 1, I will check bombs 2, 3, 5, and 9. If they were already detonated, I will add 0. Otherwise, I will do the DFS of those and add 1 for every bomb that exploded, since I have this result 1, and then in turn do the DFS of 2, let's say 2 exploded, and add the result of those. And as I said, therefore, I need to check all the entries in a list of that node. So for int next bump in map.get node. But what if I have an empty thing? Let's say, as we had initially, 3 didn't exist. This will give me an error, so I will use get or default instead of get, and my default case, in case I didn't find it, would be an empty array list. I'm missing a column here, so after I get that list for that node, I'm gonna traverse each entry in it, which is the next bump, and do the DFS of the next bump and add its result to my current result. So result is plus equal DFS next bump, and of course we need to pass the visited. So what we have right now is, if we already visited a bump, we're gonna add 0 to our result, or return 0 right away. So in that case, result plus DFS, which returns 0, would keep our result as it is. Otherwise, we will mark our bump as detonated and check all its neighboring bumps that might explode. If they have exploded, we add 0. If they haven't exploded, we mark them as detonated and see what they can detonate in turn. At this point, my problem is solved. I'll check it for missing semicolons or some mistakes. Yeah, I forgot to correct this. So I'm gonna start initially for every node, for every initial node, I have no detonated bumps, and therefore I can declare a new boolean bumps.length. So I have a boolean array with a length that's corresponding to the initial length of this to represent all the bumps. And this is map.get or default. It's not, and should remove the get here. And this is running. If I submit it, we can see the performance improved much. We were at the end 5%. We were at the verge of exceeding the time limit. And here we are doing much better.